All right, good day, Henry Ford students. I'm here to venture into section 7.2 of our homework exercises. And you want to follow along on page 499 of the textbook, you by all means do so. So let's start with number 3 as our first exercise. And what we're doing here is we are multiplying, then simplifying these rational expressions. So much like we do with numbers, we are going to do the same process with these rational expressions, which of course involve variables as well as numbers. So a couple ways of going about doing this type of problem is I can simplify first, or I can multiply across and then simplify. So if I chose to do that, it would be, what's the rule for multiplying fractions? Numerator times numerator and denominator times denominator. So I would end up with the numerator being 8x to the 6th power and the denominator being 8x to the 2nd power. And simple enough, you can see that the 8's cancel out. And I've got x to the 6th divided by x to the 2nd, which is quotient rule. Using the quotient rule, I got 6 minus 2 on the exponents, which gives me x to the 4th. All right, so that's my answer for number 3. Okay, next problem is number 5. And this is our get up and set up. And notice what they do to test our knowledge of fractions. They put the b to the 3rd in the middle as the second factor. And we are conditioned to know that any whole number, which this b to the 3rd represents, is a numerator. So if you want, you can visualize the b to the 3rd over the 1, but it's going to be multiplied to the numerator on the left side. So I end up having 5a to the 2nd, b times b to the 3rd is b to the 4th, and then I'll divide that by the 30a squared b squared, which is the denominator, times 1, if you want to go ahead and visualize that. So I just bring this over, 30a squared b squared. Okay, and then I simplify what I've got left here. So what have I got? 5 over 60 is the same as 1 over 6. All right, a squares, these cancel out. And I've got b to the 4th over b to the 2nd, which simplifies to be, I'll make this 1 the b to the 2nd power. Okay, and this would be my answer then. Easy enough, right? Okay, now we see a little change in our problems. We're going from monomials, the multiplication of rational expressions that are monomials, where we can treat them much like whole numbers, or numbers in general, to binomials. So what we want to do now here in this portion, when we get into binomials, is that I want to think in terms of factoring. I want to factor first and then see if I can do any canceling and simplifying before I multiply everything over. So this 6x plus 6, I can factor that to be, I'll do it over here. So this 6x plus 6 is going to be 6 times x plus 1, and that'll be over 5, times 10 over this 36 plus 6 I can factor by pulling out a 36, and I've got x plus 1 as well. Okay, now that they're factored, now I can do some simplifying. So let's see here. I've got 5 goes into 5 once, and 5 goes into 10 2 times. I could do 6 goes into 6 once, and 6 goes into 36 6 times. I could do 2 goes into 2 once, and 2 goes into 6 3 times. And lastly, I've got x plus 1 and x plus 1. These cancel out. So after all is said and done, I'm ending up with, make sure I get everything here when you do all this crossing out, I'm going to have 1 over, and it looks like 3. So all that simplifies to be 1 over 3. Okay, how about number 13? Remember in this chapter 7, I'm thinking factor, 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 everything, and then we can simplify. So what do I know here? Let me venture over here. I think I'll come down here and do my workspace here. So the numerator here, x squared minus 25, is a difference of 2 squares. So I can factor that to be x minus 5 times x plus 5. My denominator I can factor. Lead coefficient is 1, so I'm just going to set up my parentheses and fill it in. So I have x and x, a minus sign, and this will be a plus sign. And then what are my values going to be? Looks like it's going to be 5 and 2. Okay, so we're good with that, and it's going to be multiplied times this x plus 2 over x. Nothing to do on that right fraction. Alright, so when we simplify now, I've got an x minus 5 here and an x minus 5, x plus 2 and an x plus 2 here. So after it's all said and done and the dust is settled, I've got left x plus 5 over x. And there's my answer for number 13. All right, for number 17, we begin problems that involve division now of these rational expressions. And remember, the properties are the same for rational expressions as they are for whole numbers. So I got an example of what we do with division. And what, if you remember from elementary school, we keep the first fraction, the 5 over 6, change the sign from division to multiplication, and then flip the second fraction. So that becomes 12 over 10. All right, then at this point we can simplify our problem, our numbers here. Okay, and we end up with something like 2 over 2, which equals 1. So the same process occurs for rational expressions. So we start off with monomials, and then we'll grow into a little more complicated type problems. So here I've got this 5, I'll write it out, this one, 5x to the 7th over 2x to the 5th. That stays the same. The sign changes from division to multiplication, and we're going to flip the second fraction. So I got 4x to the 3rd is the numerator divided by 15x. Okay, now from here you can either multiply it across first or do your simplifying now, however you see fit. So this time let's say we do our simplifying here. So I got 5 goes into 5 once, 5 goes into 15 3 times, 2 goes into 2 once, and 2 goes into 4 twice. Okay, so it looks like I've got 2/3. I can put that over here now just to get it out of the way. And then I got to take care of my exponents here. So x to the 7th divided by x to the 5th. I know that's going to simplify to be x squared up top. Better circle it or something so it doesn't get lost. Then I got x to the 3rd divided by x, which gives me x squared in the top as well. So what does that mean? That means I'm going to have x squared times x squared, which is x to the 4th, in the numerator. Okay, and this is what I end up with for my answer. There's a couple of different ways of doing this, so I'm just showing you the one. If you want to multiply everything across, by all means do, and then simplify it. Okay, so that's number 17. Okay, so here we've got another rational expression. Same process now as we did with the previous problem, where I can take this and flip it around. Keep, change, flip is what we call it. So instead of writing all this out again, I'm just going to take this second one and flip it. So this division sign becomes a multiplication symbol, a big dot. And then I'll take this and flip it. So this is going to be 8x over 2x minus 12. Okay, and so this is now gone. So it's this times this. So let me do some factoring first, and I'm going to factor this denominator here, and that's going to be 2 comes out, and I've got x minus 6 left. Okay, so that means this is gone. And now everything's broken down enough I can simplify it. So what I notice is the x minus 6's we can cancel those. What else? I got 4x goes into 4x once. 4x goes into 8x twice. I'm okay with that. And oh, look at us. 2's cancel out. So after everything is canceled, and I'm going to simplify it by just taking over the x plus 4. And that's my answer. Next problem. Number 25. All right, keep, change, flip. So let's start with this top left fraction and factor that, because this is a difference of two squares. So this would be m minus n times m plus n. Okay, over m plus n. Sign changes to multiplication, and then I'm going to flip this one, this second fraction. Before I flip it, I'm going to factor this m squared plus nm. So what can I do here? And I'll write my answer down here where it belongs, in the numerator. I hope you're following me here with that. I'm going to flip it. This is going to go up to the top, so I'm just going to simplify this and put my answer here. So that means an m comes out, and I'm left with m plus n. Okay, and then this m in the numerator in the original problem is going to be in the denominator as such, like that. Okay, and I'm ready to go. So what happens? I've got m plus n over m plus n. Those cancel. I've got m's here that cancel. And so it looks like I'm left with m minus n times m plus n. And I'm done. You don't have to multiply those together, remember. Leave them factored, and that will be acceptable as our answer without having to do any additional work to that problem. Okay, thank you. Okay, number 27. This is division as well, obviously. And let's just, away we go. This stays the same, the x plus 2 over 7 minus x times, and then here I can see these trinomials. I'll be able to factor these. So the denominator is going to become the numerator, and let's factor that first. And then the numerator will become the denominator. We'll do that second. So the denominator first, we which is going to go here. It's going to be x and x, a minus and a minus. And then what am I going to have? 7 and 2. Okay, hope we're okay with that. The denominator, which is going to be from the numerator that becomes the denominator, after I flip it, is going to be x and x, minus and plus. And what numbers am I going to choose for this? How about 6 and 1? No, that's not going to work. Negative 6 times 1 is negative 6. So I need not 6 and 1, but 3 and 2. Oh, I'm messing up here. So this is going to be minus. Okay, so I'm going to rewrite that to be x minus 3, and this would be x minus 2. That's better. Negative times negative is a positive. Add negative 3 and negative 2 is negative 5. So now we're okay. So scratch this off. And now I'm going to go on and simplify everything. So what have I got? X minus 2 and x minus 2. That can go. I've got 7 minus x and x minus 7. All right, that cancels and becomes what number? Negative 1. Let's say negative 1. I'll circle that, make sure I don't forget it. All right, and that's everything. So I bring it over, and I'm going to have x plus 2 over x minus 3. And what's missing is the negative. So I can put the negative out front here. And that's satisfactory and a correct answer. Okay, I skipped over a couple of problems so you kind of get the idea of what's happening with these multiplication and division of rational expressions. And now I'm going to go do number 45 here. It's a little bit different than what we've had, and I want to be able to show you what to do with that. And then we'll have one more problem after that that is looks painful, so I want to walk you through that one. So anyway, for this one, I majorly see this numerator here being a trinomial where the lead coefficient is not 1. So we have to do the grouping method for factoring that. Okay, along the same time, I'm going to simplify everything else and factor it. And let's begin with this top numerator on the left side. Okay, so I'm gonna write everything below it as far as my answers go. Any workspace I need, I'll do it over on the right side. So here my numerator here, I'm going to factor out a 5, and I've got x minus 4 left. Okay, so that's easy. The denominator, I'm going to factor out an x, and what's left is 3x plus 1. Okay, times this top right numerator now. I've got to factor that, so let's do that over here. So it's going to be 3 times 4, which is 12. 2 factors of 12, that give you 13. So that's 12 times 1. And then I'm going to rewrite this to be 3x squared plus 12x plus x plus 4. Seems to me we have this one already. Alright, so when I group this now into two binomials, I'm going to pull out a 3x, and what's left is x plus 4 plus, on the right binomial, I'm going to take out the 1 and write what's left over, which is x plus 4. So now I can see over here, I'm going to put my factored form of this problem as x plus 4, and what's left over here is 3x plus 1. Okay, so that's the additional work we had to do on this problem. And now I've got this denominator to factor, and what do you notice about it? It is indeed a difference of 2 squares. So this factors to be x minus 4 times x plus 4. There, everything's factored, everything's in the right position. This is multiplication, so notice no flipping going on. And so let's just do our canceling. So I've got x minus 4 here and x minus 4 here. Cancels to be 1s. 1. And then I got a 3x plus 1 here and a 3x plus 1 here. So those cancel out. And it looks like that's it. So I'm going to bring everything over, and it's going to be 5 times x plus 4. So I'm going to write it as 5 times x plus 4. And put that over x. And there's our answer. Okay. All right, our last problem is a relatively major problem, as you can see, where we have to divide the first set of fractions in the parentheses and then multiply it by this x squared plus y squared divided by 6. All right, so let's take care of what's in the parentheses here first. And so I'm going to start with this first fraction here and factor the numerator, and I'm going to do this underneath it. So it's going to be x minus y times x plus y and divided by x squared plus y squared. Remember, this is a difference of 2 squared. This is a sum of 2 squares, so we cannot factor that. That is in its prime form. All right, so that's factored. I'm basically keeping the first fraction, changing the sign to multiplication, and then I'm going to flip the second fraction. So the 3x goes up top. The numerator comes down to the bottom, and that's a difference of 2 squares, so I'm going to factor that as x minus y times x plus y. Okay, and now I'm going to do nothing. I'm just going to multiply this x squared plus y squared over 6. That just stays the same. So this is where I'm at. I took care of the parentheses here, this here basically, and I'll multiply it to this x squared plus y squared divided by 6. And so this just means I can start canceling. So this is nice up here. These cancel out. These two binomials, they're gone. And the x squared plus y squared, these cancel out. And then I've got 3x over 6 left. That's going to give me 1/2. And so when it's all said and done, I end up with x over 2. X over 2, and that's it. Looked a little more intimidating than what it was, or what it is. But, okay, that's it for 7.2. All right. See you later.